Hello students, welcome back to physics class. This video is a revision of motion chapter. So today we are going to discuss some important questions regarding FA1. So listen carefully, okay? So these are the topics today we are going to cover. So all these topics we're going to cover. First is physical quantity. So what is physical quantity and scalar and vector? Next is difference between distance and displacement, speed and velocity, and uniform and non-uniform motion. After that, we need to discuss about acceleration and types of acceleration like positive acceleration, negative acceleration, and zero acceleration, graphical representation of motion, equation of motion, and uniform circular motion. So first topic is physical quantity. So what is physical quantity? Already we have discussed the quantity which we can measure physically. So whichever the quantity we can able to measure physically is called physical quantity. Mass, length, area, volume, speed, velocity, all are physical quantities, okay? And all these physical quantities we can categorize into two types. One is scalar quantity and one more is vector quantity. Scalar quantity means quantity which has magnitude and there is no direction. No direction at all. While measuring those quantity, we are not supposed to consider direction. Only the magnitude. Magnitude means the amount is enough. For example, mass, distance, speed. So these are the examples of scalar quantity. Next is vector quantity. The quantity which has both magnitude and direction. So while measuring this quantity, we need direction as well as magnitude. For example, weight, displacement, force, velocity. So these are the examples of vector quantity because while measuring these quantity, we have to consider magnitude as well as direction. Next, these are the examples of scalar and vector quantity. So you can go through this once. See, you're going to get any one question in this concept. We may ask like the followings are the vector quantity. So which are the vector quantity? We may give four options. So you have to know that. So which is vector quantity and which is scalar quantity. Examples you have to remember. For example, distance, displacement, acceleration, force, weight, momentum. So these are vector quantity. Okay. And these are scalar quantity. You can go through these examples. Is it clear? Next, difference between distance and displacement. So what is meant by distance and displacement? See, distance means actual path covered by an object from one position to other position. It may be any path, it may be curved path, it may be circular path, okay? So that we can call it as a distance. Displacement means a shortest distance, or you can call it as a shortest path covered by an object from initial to final position. Is it clear? So these are the definitions. Next, distance has only magnitude and there is no direction. What about displacement? So displacement has both magnitude as well as direction. This is the reason distance is a scalar quantity and displacement is a vector quantity. Next one you see, distance never be zero and displacement may be zero. Is it clear? So distance never be zero and displacement may be zero. Next is obviously a scalar quantity. Distance is scalar and displacement is vector. Next, distance measured is always positive. So it is always positive and displacement can be negative, positive, or that depends on the reference point. Is it clear? So this is the difference between distance and displacement. Regarding this distance and displacement, you may get one question. Okay, and listen here. So this is a question. An object has moved through a distance. Can it have a zero displacement? If yes, support your answer with an example. They're asking, is it possible a displacement will become zero or not? Yes. So zero displacement is possible. When you know if an object moved through a circular path at a distance in a circular path, one complete circle means when initial and final position of the object is same, displacement will become zero, but distance never be zero. Keep in your mind. Okay. Next example. Suppose a body moving in a circular path it start from A and return back to the same point A after completing one revolution. The distance will be equal to circumference of circle, and while a displacement will be 0. So displacement will become 0 here. Is it clear? So displacement may be 0 but distance never be 0. So one question you will get from these for 1 mark, distance or displacement. Is it clear? I hope you clear the concept of distance and displacement. Next is uniform and non-uniform motion. So the all kind of motion we have categorized into two types. One is uniform and second one is non-uniform motion. Uniform motion means if an object travels equal distance in equal interval of time. So it is said to be an object is in uniform motion. For example, you see here time is 0 4 2 second 2 second 2 second for each 4 meter. A car covers 4 meters in each 2 seconds. This we can call it as a uniform motion. Non-uniform motion means if a body travels unequal distance in equal interval of time. Unequal distance and equal interval of time. You can see that 0 1 1 meter, it covers 1 meter in 2 seconds, it covers 10 meter in another 2 seconds, another 2 meter, it covers 10 and 25, so 15 meters. So it is equal interval of time and unequal interval of distance. Okay, if your body travels unequal distance and equal interval of time is known as non-uniform motion. Next is a difference between speed and velocity. So what is the meaning of speed and velocity? See, practically speed and velocity are same. Only thing is speed, there is no direction, but velocity has direction. Is it clear? So now we'll go one by one. Speed. Distance covered by a body with respect to time is known as speed, or distance covered by an object with respect to time is known as speed. And what about velocity? Velocity means instead of distance we can see the displacement. Displacement of an object with respect to time is known as velocity. So formula to calculate speed is equal to distance divided by time. Velocity is equal to displacement divided by time. Next, speed has only magnitude. That should be HAS. Okay, that is not AS as HAS. Speed has only magnitude and there is no direction. Velocity has both magnitude and direction. Obviously, speed has only magnitude means we can call speed as a scalar quantity. Already we have discussed about that. So speed is a scalar quantity and velocity is a vector quantity. And speed never be 0. Why? Because distance never be 0, no? So distance never be 0 means obviously speed never be 0. But velocity may be 0. When velocity will become 0? Obviously when displacement are 0. Already we have discussed displacement may be 0 but distance never be 0. So velocity may be 0, positive and negative. I hope you clear this difference between speed and velocity. Next is average speed and average velocity. So you have to remember that. So what is meant by average speed and what is meant by average velocity, okay? And 100% surely one sum you will get regarding average speed and average velocity. Average speed means it is a ratio of the total distance traveled to the total time taken. Or formula you can write average speed is equal to total distance traveled divided by total time taken. Next is average velocity. Average velocity means is the ratio of total displacement to the total time taken. So average velocity is equal to total displacement divided by total time taken. So these two formulas you have to remember. Is it clear? Next we are going to discuss one or two sums regarding average speed and average velocity. So these are the very important sums. During an experiment, a signal from spaceship reaches a ground station in 5 minutes. So during an experiment, a signal from spaceship, it reaches to the ground station in 5 minutes. What was the distance of spaceship from the ground station? So we need to find out the distance between ground and spaceship. The signal travel at the speed of light 3 into 10 to the power 8 meter per second. So here speed of light they have given and they have given time. So we need to find out the distance between spaceship and ground station. Okay, first you can write given what they have given, time taken to reach signal from spaceship to ground, or else you can write it as a t is equal to 5 minutes This you have to convert into second because speed they have given in meter per second. See, while doing the sums, these conversions are very important. 5 minutes, if you convert into seconds, it will become 300 second, because 5 into 1 minute is equal to 60 second. So 5 into 60 is equal to 300. So speed of light is 3 into 10 to the power 8 meter per second. Okay, we need to find out distance. Now formula, we know that the speed is equal to distance divided by time. So if you want to calculate distance, speed will go to a left hand side, so distance will become speed into time. So now you can multiply that. Speed is 3 into 10 to the power 8 into 300. So that is 3 3s are 9. And how many zeros are there here? 2 zeros you can add up with the power. So that will become 10 to the power 10 meter, or 9 into 10 to the power 7 kilometer. So therefore the distance between spaceship from the ground is 9 into 10 to the power 7 kilometer. So this is how you can find out the distance between any two objects. Is it clear? Next sum. This is very important sum. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other end, and she covers total distance she covered, because the total distance of the pool is 90 meter. She goes and come back to the original path itself, original point itself. It will become 90 plus 90 is 180. That is the total distance traveled. So back along the same straight line path, find average speed and average velocity of Usha. So we need to find out average speed and average velocity. Is it clear? So now first we have, what is the formula to calculate average speed? Average speed is equal to total distance divided by total time taken. So now we need to find out total distance first. So 90 meter plus 90 meter is equal to 180 meter. Already they have given. So once again I have written here. So 90 meter plus 90 meter is equal to 180 meter. So 180 meter is a total distance traveled. Next, total time taken. So the total time taken is equal to 1 minute, that is 60 seconds. So you have to convert into minute to second. So, and what about displacement of Usha? See here, the displacement of the Usha is 0. Why? Because initial and final position of Usha is same. Is it clear? So now we are going to calculate average speed. So average speed is equal to total distance divided by total time. So total distance is 180 meter divided by 60 second. If you simplify, 0 0 get cancelled and 6 1s are 6 3s are. So 3 meter per second is the average speed. Next is average velocity. So the average velocity is same formula, total displacement divided by total time taken. So already we know that displacement is 0. Why? Because initial and final position of the Usha is same. So now 0 meter divided by 60 seconds. So 0 divided by 60 is 0. So now average velocity is 0. So why average velocity is 0 here? Because our initial and final positions are same. So the average speed of Usha is 3 meter per second and average velocity is 0 meter per second. So this is very important sums. You can practice yourself. Next, so these are the two sums you can practice. Next is acceleration. So the meaning, next concept is acceleration. So now sometimes all the object as changes velocity, so that we can call it as acceleration. Here I have given a two pictures. That is the accelerator. We can call it as accelerator or accelerator of a car, accelerator of a bike. Okay, so what is the uses of that accelerator? We can increase the speed or decrease the speed. So an object moving with some direction, so we can call it as a velocity. Now the definition of acceleration is the quantity which specifies changes its velocity is acceleration. So acceleration is just like a term. Instead of changing velocity, we can call it as an acceleration. So how to define acceleration here? Acceleration is defined as the rate of change of velocity with respect to time. Acceleration can be defined as rate of change of velocity with respect to time, means change in velocity with respect to time. Acceleration is equal to change in velocity divided by time taken. So acceleration is equal to, how to find out the change in velocity? That is final velocity minus initial velocity divided by time taken. So now A is equal to V minus U by T. V stands for final velocity and U stands for initial velocity throughout the lesson. Okay. So A is equal to V minus U by T. is a formula to calculate acceleration. Is it clear? This is very important formula. Surely one sum you will get regarding acceleration. So regarding this, what is first you have to know that what is final velocity and what is initial velocity in the given. Okay. Next is the SI unit of acceleration is meter per second square. See here how to write meter per second square. M divided by S square. Okay. The SI unit of acceleration is meter per second square. You see whether acceleration definition and acceleration SI unit, one question 100% surely will get. Okay. So you can practice this. What is acceleration and SI unit of acceleration? SI unit of acceleration is meter per second square. You see that how to write SI unit of acceleration, meter divided by S square. Next is types of acceleration. So we have three types. Positive acceleration means the way of changing velocity. So if in case velocity increases, what happens? Velocity decreases means what happens? So velocity is constant means what happens? It means what kind of acceleration we can call it as. So first is positive acceleration. Positive acceleration means acceleration is positive when an object increases its velocity. If an object increases its velocity means acceleration will become positive. If an object comes from rest to motion, we can call it as a positive acceleration. For example, pressing accelerator of a car. So pressing accelerator of a car is an example of positive acceleration. Next is negative acceleration. So negative acceleration or retardation, or we can call it as a deceleration also. Okay. So when acceleration will become negative means acceleration is negative when an object decreases velocity. If an object decreases its velocity, what happens? Acceleration become decreases. So that we can call it as a negative acceleration. For example, pressing the brake of a car. So if you press the brake of a car, what happens? Velocity decreases, so acceleration will become negative. Instead of that, we can call it as a object comes motion to rest. So motion to rest, we can call it as a negative acceleration. Last one is acceleration is zero. When acceleration will become zero means when an object has constant velocity or moving in uniform velocity. Okay, if an object moving in uniform motion, acceleration will become zero. Why? Because there is no change in velocity at all, because in uniform motion an object covers equal distance in equal interval of time, so it is a constant velocity. So there is no change in velocity means acceleration will become zero. Is it clear? So one question you may get in types of acceleration, like what we can ask, in an uniform motion the acceleration will become dash. What it becomes? Acceleration will become zero. Keep in your mind, in an object moving in uniform motion acceleration will become zero. Is it clear? Okay, I hope you clear the concept of types of acceleration and acceleration. So now equation of motion, already you know that. So what are equation of motion? We have three equation of motion. So here you have to remember, along with this equation of motion, what it describes. So first equation, what it describes. Second equation, what it describes. For example, what is the first equation of motion? V is equal to u plus at. What it describes? This equation describes, or this equation of motion describes velocity time relation. It gives the relation between velocity time relation. Second one, S is equal to ut plus of at square. S is equal to ut plus of at square. This equation of motion represent position time relation. It gives the relation between position and time. This you have to remember. Okay. Last one is v square is equal to u square plus 2as, or sometimes we can write v square minus u square is equal to 2as also. Okay, this is third equation of motion. This equation of motion represents the relation between position and velocity. Which equation? V square is equal to u square plus 2as, or v square minus u square is equal to 2as. So in equation of motion we may ask like the following equation, or v square minus u square gives the relation between dash and dash. What it gives? It gives the relation between position and velocity. So you have to remember like that. All these equation you have to remember like that. One question you may get in this equation of motion. Okay. Next, so we need to discuss some problems regarding acceleration and equation of motion. Okay, one or two sums you may get regarding this equation of motion and acceleration. See, 4 to 5 marks you may get sums only. Okay, so here is the first sum. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. So in exam we may give in 5 hours. So in 5 hours means no need to change this velocity and all. Here they have given time in seconds, so that's the reason we are changing velocity into kilometer per hour to meter per second. Is it clear? If they have given like 5 hours means no need to convert that conversions of initial and final velocity at all. Is it clear? So a bus decreases its speed. Decreases means bus is already in the motion, so it comes to rest. Why? Because it decreases speed. So now initial velocity is 80 kilometer per hour and final velocity is 60 kilometer per hour. Everyone will do here only the mistake. Be careful. You have to know that which is initial velocity and which is final velocity. Is it clear? Here object decreasing speed from 80 to 60 km per hour means 80 km per hour is initial velocity and final velocity is 60 km per hour. Next, conversion part. So kilometer per hour to meter per second. So 80 into 5 by 18. So if you simplify that, you will get answer 22.22 meter per second. Next, here also in final velocity 60 kilometer per hour. If we convert into meter per second, 5 divided by 18 we have to multiply. So we will get answer 16.66 meter per second. Next, substitute the value. Time they have given 5 seconds. Substitute the value of initial and final velocity. A is equal to v minus u by t. Substitute here, you will get answer. A is equal to means acceleration is equal to 1.112 meter per second square. Is it clear? So this is very simple and very easy sum. You have to know that which is initial velocity and which is final velocity. Next, this is one more sum. This is regarding equation of motion. So how to select the equation of motion means first we have to write the given data. So by using given data you can select the equations. See first one, second question, this one, a bus starting from rest. So you have to remember wherever you get a bus or any object starting from rest means initial velocity will become 0. Keep in your mind. Okay, if in case a bus finally come to rest means final velocity will become 0. Keep in your mind. A bus starting from rest moves with uniform acceleration of 0.1 meter per second square for 2 minutes. Find a speed acquired, the distance traveled. Second one is distance traveled. So we need to calculate speed acquired means obviously that is final velocity. Okay, first you write down given initial velocity will become 0 meter per second. First one, final velocity v we have to calculate. V is question mark. And second one, distance traveled. Distance traveled is nothing but s. So s is question mark. And acceleration also they have given 0.1 meter per second. Time they have given in minute, so you have to convert it to second. T is equal to 2 minutes. 2 into 60, that is equal to 120 second. Next, speed acquired means final velocity we have to find out. Obviously we can use first equation of motion itself. V is equal to u plus at. Substitute the value here. V is equal to 0 plus 0.1 into 120. So 0 you can remove that. 0 if you add up with 0 you will get same number itself. So 0.1 into 120 will become 1 into 12 because I'm going to shift the point here. So 1 into 12. So V is equal to 12 meter per second. Next, distance travel, we know formula, second equation of motion. S is equal to ut plus half at square. S is equal to 0 into 120 plus half into 0.1 into 120 into 120 because a t square means 120 square. So 120 square become 120 into 120. Next, 0 into 120 is 0 only plus 1 into 6. 1 into 6, how 6 you know? 2 ones are 2 60s are, and you can shift the point here, that will become 6. So 6 into 120. So yes, our distance traveled is equal to 720 meter. I hope you clear this concept, means this sum. Okay, next one more sum. This is very important sum and very simple sum. A trolley while going down an acceleration of 2 meter per second square, acceleration they have given here, what will be its velocity 3 seconds after the start? After the start means obviously trolley should start from rest. So trolley should start from rest means initial velocity will become 0. We need to find out velocity after 3 seconds start means we have to find out final velocity. Given, first you write out given a is equal to 2 meter per second square and u is equal to 0.0 meter per second square, sorry, 0 meter per second. Final velocity we have to find out, time they have given 3 seconds. So first equation of motion itself we can find it because everything they have given. So v is equal to u plus ad square. V is equal to 0 plus 2 into 3. So 2 into 3 if you multiply it will become 6. So 6 meter per second is a final velocity. See, these type of sums you may get in multiple choice question. So you have to work out in multiple choice question, two or three sums, two sums you will get. So you have to work out and you should tick the answer in multiple choice question. Simple sum you will get in multiple choice question. Next is graphical representation of motion. This graphical representation of motion we'll discuss in next video. Okay.